Derivatives of logarithmic functions. The first example is f of x is natural log of x. So when you take the derivative of natural log of x, we write the notation f prime x will be just 1 over x. And you know that the domain of this function is x greater than 0. So 1 over x is absolutely okay. The second one, we have natural log x squared. So e square is on x. So with the property of logarithm, you can pull your 2 in front. It's not the derivative though. It is just the property of logarithm. Now when you take the derivatives, so derivative of this will be 2 is a constant. Derivative of natural log of x is 1 over x. So your answer is 2 over x. Now when I'm going to the third example, in this case, I cannot pull these 2 in front. It doesn't follow any property. So then you can use the chain rule, like think that natural log of x is just your single function x. And then like the derivative of x squared will be 2x. So we'll be exactly following that one. We said 2 natural log of x, and then derivative of inside natural log of x will give me 1 over x. So this is the derivative. This one is very important function. You can use as a chain rule. So that natural log of 5x is 1 over 5x, and then derivative of 5x will give you 5. So 5 cancelled out. You get 1 over x. This is very important to know. Otherwise, you can think like this. Natural log of 5 and then natural log of x, because this is the property of natural log of a times b is natural log of a plus natural log of b. And now natural log of 5 is constant, so that the derivative of constant is 0, you know. So then derivative of natural log of x 1 over x. I'm going to the next example where your function is natural log of x base a. So now I have base a. I do not have direct formula for that. So then what do? We change the base. You can write natural log of x over natural log of a. So they are equivalent. So then when I'm taking derivative of this natural log of x over natural log of a, you can consider natural log of a is a constant. So pull it outside. So you can say f prime x is 1 over natural log of a. This is the constant, I leave it outside, and natural log of x is 1 over x. So you can simply say 1 over x natural log of a. That's your derivative. This function here, natural log of e to the x, is just like x you can pull in front, and then you can say that it is natural log of e. So natural log of e, everybody knows that it is 1. So then my function, I can just a simple x. Now when I take the derivative of this function, it's just 1, because the derivative of x is 1. Okay. We are now taking one function, f of x is 13 to the x natural log of 7x. So this should go with the product rule when you take the derivative. So then 13 to the x is one function, natural log of 7x is another function. So 13 to the x is just like a to the x. And you know the derivative of a to the x is just a to the x natural log of a. So my a is 13. So I will say that this derivative is 13 to the x and then natural log 13. And you know that the derivative of natural log of 7x is just 1 over x. So then you just take the cross multiplication and then add together. That will give you the derivative. So then my f prime x in this case will be, when I multiply like this, I get 13 to the x over x plus 13 to the x. Then I have natural log of 7x times natural log of 13. So this is the derivative for this function. So I'm going to the next example. I have my function is 3 over natural log of x squared plus 3. So this function can be written as 3 natural log x squared plus 3, and everything should have under the exponent -1. Now if you apply the chain rule, f prime x will give you negative 1 goes in front, so it's negative 3. Then you have natural log of x squared plus 3 to the negative 2. Now the derivative of inside will give you 1 over x squared plus 3, and then x squared plus 3 further will give you 2x. So you are actually done. If you want, you can further simplify and write the nice form. Otherwise, I'll say that you are done with your derivative. The next example. This function, you need to see the exponent exactly. So natural log of 4 minus x, everything has exponent 1/3. Now just apply power rule and the chain rule. So f prime x, 1/3 goes in front with the power rule. Natural log of 4 minus x to the negative, you can see 1/3 minus 1 will give you negative 2/3. And then derivative of natural log of 4 minus x will give you 1 over 4 minus x, and the derivative of inside will give you negative 1. So further, if you simplify, you can write your simplified answer. Otherwise, I will say that you are done. Now let me go to the next one. So the next one should go with logarithmic form base change. So first you can say natural log of 5 to the x over natural log of 6. Now in this, the simplified version, x goes in front, and then you have natural log of 5 over natural log of 6. This is just your simplification of the function. Now when you take the derivative, f prime x, so derivative of x is 1, so remaining will be natural log of 5 over natural log of 6. You are done. Now this example, I can say that this whole expression under the radical sign will have exponent 1/2. So that 1/2 exponent I can bring in front, and the natural log of 3x plus 5 can be written as 3x plus 5 minus natural log of 7x minus 4. So what I'm using, all properties in here are just from pre-calculus. So now if you take the derivative, it will be f prime x, keep your 1/2. Natural log of this will give you 1 over 3x plus 5 times 3 minus 1 over 7x minus 4 times 7. So you are done for this problem too. So keep note on this one. I need some space, so I'll remove it and go to the next example. Okay. So in my next example, I'll be using logarithmic properties. Using the properties of logarithm, I'm getting 5 in front, natural log of x, plus natural log of 2 plus 3x, plus natural log of x squared plus 5. Now when you take the derivative, f prime x, 5 is a constant, natural log of x will give you 1 over x, so 5 over x. So now this one is giving you 1 over 2 plus 3x, and derivative of inside will give you a 3, plus you get 1 over x squared plus 5, and derivative inside will give you 2x. So we are completely done with derivative of logarithmic functions.